Hi, my name is Caterina Strambio de Castiglia, and I'm presenting this tutorial on behalf of several community initiatives, including the 4D Nucleome Network, Bioimaging North America, and Quadreplimi. In this tutorial, you will learn about Micrometa App, which is an interactive software tool that was developed to facilitate the collection of microscopy metadata based on the 4DNB Naomi newly developed community-driven specifications. You will also learn how to perform some basic tasks using Micrometa App and therefore get started using this tool. This tutorial will be organized as follows. There will be a brief introduction in which I will tell you a little bit more about the 4DNB Naomi microscopy metadata specifications. Then you will learn about a suite of easy-to-use interoperable tools that were developed to collect this metadata. And then I will give you a brief introduction about Micrometa App. Then we will review the tutorial objectives and review the material needed for you to perform this tutorial. Then we will perform a hands-on Micrometa App demo in which I will go through the different steps that are required to get started. And then finally, we will review documentation material that you will need to learn more about this app. So let's get started. Accurate documentation and quality control are essential to ensure the quality, reproducibility, and sharing value of imaging experiments. A typical imaging experiment involves 3 steps: sample preparation, image acquisition, and image data analysis. All 3 steps have to be documented using specific types of metadata, from experimental sample metadata to microscopy metadata to image analysis metadata. In this tutorial, we're concentrating on the microscopy metadata, which documents the acquisition of images to produce pixel image data. This is metadata that has to be associated with the pixel image data to document how the images were acquired, using which instrument, and using which settings, and what kind of quality control procedures were performed to ensure the quality of the resulting data. So, the specifications that were recently published on Nature Methods in the focus issue dedicated to this topic are called 4DNB Naomi, or NBO for short, and define the metadata model that is used by Micrometa App. Before we continue any further, I would like to explain to you what we mean by a metadata model. A metadata model is literally a schematic representation in which the different information that is needed to understand and interpret data are organized in a structure. In this case, for example, the structure allows to recognize that an objective is part of an instrument and to know what kind of information need to be collected about the objective, such as, for example, magnification, numerical aperture, and correction. It is important to always remember that this schema does represent an actual physical object or a real-life situation. So in this case, the instrument box represents the whole microscope, which is composed of different components, such as, for example, this box represents an actual objective that is mounted on the nosepiece of this microscope. In order to bring this specification and this model into life, it is important that we use tools that make it possible for people to utilize the metadata specifications enclosed in the NBO model to document their imaging experiments. To achieve this goal, a set of 3 tools were developed. In other tutorials, you will be able to learn about MDMIC and MethodsJ2. In this tutorial, you will learn about Micrometa App. Micrometa App is subdivided into 2 parts. In the first part, one collects the information to describe the hardware of a given microscope to produce a microscope JSON file that can be used over and over again to document all the images that are produced using a given microscope. In this part of the app, which is called Manage Instrument, we literally drag and drop icons representing individual components on the canvas and enter information about each of the components by clicking on the icon and filling in the corresponding form. We then produce a microscope JSON file that can be used over and over again in the second part of the app, in which we collect the acquisition settings for a given image. In the Manage Settings part of the app, what we do is we select a given microscope, we select an image we want to annotate, and the application uses bioformats to automatically import metadata that is already present in the image file header. Then, there is a series of interactive windows that allow you to enter additional information and select which subset of the hardware components was used for this specific image and enter settings about each of them. Before I go any further, I want to make sure to acknowledge the funders, NIH and Chan Zuckerberg, my institution, the 4DN Nucleome Network, Bioimaging North America, Quarep Liming, and Alex Sirigano, who is the software developer extraordinaire who is responsible for developing Micrometa app.